Hello everyone, my name is Ojas Satbhai and today I'm going to demonstrate an experiment based on Bernoulli's principle. Using a simple and fun setup with just two plastic bottles, a connecting pipe, and water. Bernoulli's principle helps us to understand how pressure and the fluid velocity are related. When the velocity of the fluid increases, the pressure within it decreases. This principle explains many real-world phenomena like how planes fly, how carburetors work, and even how perfumes are sprayed.
Moving towards the explanation of the setup. For this experiment, I have used two 2-liter plastic bottles. These bottles are connected at the top middle part using a flexible pipe. One of the bottles has also a nozzle through which we can pour water. So here is how the setup works. One bottle is filled with water and other is empty. When we introduce water to the nozzle into the empty bottle, it creates a pressure difference. This increase in pressure at the first bottle forces air to flow through the connecting pipe into the second bottle, which is full of water. This air pushes down the water in the bottle, causing it to fall out through a pipe into the empty bottle. Amazing. So, here's how the Bernoulli's principle works here. This process happens because of the Bernoulli's principle and the relationship between pressure and the fluid motion. When we introduce water into the empty bottle, we are actually compressing the air inside it. This increases the pressure in that bottle. Air naturally flows from high to low pressure, as we know. So it rushes it to the second bottle, the one with water. This added pressure in the second bottle pushes the water down and the water exits through the pipe. So basically, the air is acting as a piston or pump, helping us to move the water without any external motor. The fast moving of air inside the connecting pipe causes pressure drop, assisting the flow even more. So basically, this is the idea of the Bernoulli's principle in action. So after performing this amazing experiment, I could learn and observe so many things. The moment I poured water into the empty bottle, air rushed through the pipe into the other bottle. The pressure pushed the water out into the empty one, quickly creating a flow. Even though there was no pressure or a pump there, just gravity and pressure difference made everything move smoothly. This demonstrates that when fluid or air moves faster, it creates a region of low pressure, and that pressure difference drives the motion of the other flows. In this case, we have the water. So, as we can see in the illustrated image, we have the relationship between pressure and velocity, and it's clear that as the velocity increases, the pressure decreases, and vice versa. As the pressure decreases, the velocity increases. So, now moving towards the calculation of the experiment. In this part of the experiment, we observed that it took 48 seconds to transfer 300 milliliters of water from one bottle to the other bottle. The two bottles were connected by a pipe with a diameter of 0.7 centimeters, and we had a high difference of 19 centimeters between the water levels in the bottles. From this data, we first calculated the flow rate, and then it used to find the velocity of the water flowing through the pipe, which came out to be 0.162 centimeters per second. Next, we applied Bernoulli's theorem. Bernoulli's equation was used to calculate and compare the velocity, the real velocity, and the ideal velocity. And when we calculated the ideal velocity, it came to be 1.93 meters per second, using the formula 2 root square of 2gh, where g is just the gravitational acceleration and h is the height difference. And finally, using the Bernoulli's principle, we calculated the pressure difference between the two bottles, which is responsible for the water flow of the system. So the results showed that although the theoretical pressure was higher, the real value was lower due to the friction and energy loss, as the Bernoulli predicted in the real world conditions. So to warm it up, this experiment is a great example of fluid mechanics in action. It shows how air pressure and flow rate can move liquids efficiently. I hope this gives you a better understanding of Bernoulli's principle and how can we apply physics in everyday life. Thank you for watching. See you later.